Hello students, today we're going to learn about the atomic radius and the trend of the atomic radii in the periodic table. You've already learned about trends, but here's just a quick reminder. A trend is a pattern or repetition of particular properties, okay, and this is happening on the periodic table. In the example of this class, you've already seen the trend of density in the periodic table. The periodic table is arranged in a certain way to keep elements with similar properties close together. And we especially talked about valence electrons and how those are related to groups. Today we're going to look at the trend of the atomic radius, okay, and essentially the size of the atom as well. First of all, just a quick introduction on how we determine atomic radius. Okay, as we talked about in the past, the electron cloud, okay, which occupies most of the atom, is actually very fuzzy. It's not a straight line like this graph here, but it's very fuzzy. So the way that we determine the radius of an atom is by taking two of the same atoms that are bonded together. Okay, taking the difference between the nuclei of those two atoms and dividing it by half. Okay, and that'll give us the radius. Okay, and the radius is measured in picometers. You should have already done this graph. Okay, but this is just to go over the graph that you've done in order to clarify the information. Okay, this is a graph of atomic number versus size of the radius. Okay, here, for example, we have hydrogen and helium. If we look at a periodic table, hydrogen and helium are both on period 1. And if we look here, it seems that the radius gets smaller. Okay, let's look at the elements from period 2 now, which are going to be lithium, beryllium, all the way to fluorine and neon. Okay, so essentially we are looking at this line over here. Okay, and as you can see, the radius of the atom also gets smaller as we go across that period. Let's look at the next one, period 3. That's going to be sodium, magnesium, all the way to chlorine and argon. And again, we see the same trend. Okay, so we can, the first thing that we learn from this graph is that the radius will decrease as we go across the period. Okay, and of course I'm abbreviating here. What happens if we go, I'm going to put R for radius decreases as we go across the period. What happens to the radius as we go down a group? Okay, that's our next question here. Well, if I look at group 1, I have hydrogen, lithium, and sodium. So if I look at here, hydrogen, lithium, and sodium, I see that the radius actually increases, okay, as I go down that group. If I look at the next group, group number 2, beryllium, magnesium, and calcium, I don't have calcium here, but I can see that as I go through beryllium and magnesium, it also increases, okay? And if I go over here to the noble gases, okay, group 18, I see the trend here. I have helium, and I'm just trying to connect these points so that you can maybe make it easier for you to see. Okay, I can also see that the radius is increasing. Okay, so the radius increases as we go down a group. Here's a visual representation of what the size of the atoms look like, and you can see as we go across a period, okay, that the atoms get smaller and smaller, and that as we go down a group, the atoms get bigger and bigger. So the atomic radius decreases across the period. Let's talk about why. If we look here at period 2, okay, we've got lithium. Lithium has 3 protons in its nucleus, okay, And then it's got the first valence shell with 2 electrons. And then it's got the second valence shell, not the second valence shell, excuse me, the valence shell, the second shell, second energy level with 1 valence electron. So that's lithium. Okay, I'm going to draw beryllium over here. Now beryllium is going to have 4 protons, again with 2 shells. The first one has got 2. And the second shell, which is a valence shell, also has 2 electrons. Okay, and then we're going to go all the way over here to, let's do neon. Okay, with how many protons? 10 protons in the nucleus with 2 shells. Okay, and then of course we've got 8 valence electrons for neon. Well, what happens here is that as we go, I'm going to change the color here. As we go across the period, as you can see, we're adding more protons and a greater nuclear charge. So those protons, okay, they are actually pulling these electrons closer in and pulling the electron cloud closer to the center, okay? But as we go across the period, we're adding more electrons to the same energy level, the same shell, but the nuclear charge increases. Okay, so we get more attraction towards the center of the atom. Okay, so the nucleus pulls the atom inward, pulls the electron clouds inward, and the atom actually gets smaller. Okay, because of the increased nuclear charge as we go across a period. So you can see here, there's a little bit of attraction, 3 arrows. Here we have 4, a little bit more attraction, but here we have a lot more. So as you can see, more protons, okay, bring that electron cloud closer in. So here's just a visual thinking map to help you remember. Okay, electrons are added to the same energy level, okay, while protons are being added to the nucleus. That leads us to having an increased nuclear charge, okay, pulling the electrons closer and making the atom smaller. Now, as we talked about earlier, the atomic radius increases as we go down a group, okay? Let's talk about why that happens. Well, as we go down the group, the energy levels are going to increase, okay, the number of energy levels. Here we have period 1, period 2, period 3, period 4, 5, 6, okay? These atoms here only have 1 energy level or 1 shell. Here we have 2 shells, 3 shells, 4 shells, 5 shells, 6 shells. So normally, as you think, an atom with 1 shell is going to be smaller than an atom with 2 shells, which is going to be smaller than an atom with 3 shells, and so forth. Okay, so just as we add shells, the energy we add shells or energy levels, the atom just naturally gets bigger because there are more energy levels. Okay. Now there is another factor that contributes to the increase of atomic radius down a group, and that's called shielding. Okay, we already talked about how the number of energy levels increase. Okay, so the outer electrons are farther away from the nucleus. Okay, so let's compare these 2 atoms here, one with 2 energy levels and one with 3. Well, these electrons that are on the 3rd energy level are farther away from the nucleus, okay, than the ones from the 2nd energy level. So what happens is the inner electrons are going to feel most of the pull of the nucleus, okay? And these outer electrons here are going to be free, so to speak, from the pull of the nucleus. Okay, because the inner electrons take the most of the hit. Okay, that means that the nucleus has less of a pull on the farthest electrons. Okay, so that's called shielding. Okay, the inner electrons shield the outer electrons somewhat to the pool of the protons in the nucleus, okay? And that allows the atoms to get bigger as we go down a group, okay? Um, that's all that I had for today. And please ask me any questions if you don't understand any of this.